Hello students, welcome back to the maths class. Let us start today's class by recalling the formulas which we have used in solving the problems in our previous class. So, if I take any vector, say vector A, which is in its component form, that is xi cap plus yj cap plus zk cap, then here x, y and z are called as scalar components, and xi cap, yj cap and zk cap are called as vector components of any given vector. Okay, so here not only x, y, z, we can even consider the vector in the form of a1 cap plus b1 j cap plus c1 k cap. Then a1, b1, c1 will be your scalar components, and a1 I cap, b1 j cap and c1 k cap will be called as your vector components. Next, in problems we have learned how to find the magnitude. So, for a given vector, vector A, which is xi cap plus yj cap plus zk cap, magnitude of vector A will be given by root of x square plus y square plus z square. Next, we have studied what unit vector is. We know the formula for unit vector, where unit vector is divided. It is denoted as a cap. For the vector A, unit vector is denoted as a cap. For any other vector, say if I take B or C, then the unit vector will be denoted as B cap or C cap. So vector A cap is equal to magnitude of vector A divided by magnitude of vector A. That is, unit vector A cap is equal to vector A divided by magnitude of vector A. Then, what is vector joining two points? We have studied vector joining two points. So, vector joining any two points. So, in this, let us consider point P and point Q, where point P has its coordinates as x1, y1, z1, and point Q has its coordinates as x2, y2, and z2. Then, vector joining two points is PQ. Well, vector PQ is given by x2 minus x1 the whole square. X2 minus x1 into I cap plus y2 minus y1 into j cap plus z2 minus z1 k cap. I repeat, if you have any two points, say P with the coordinates x1, y1 and z1, and Q with the coordinates x2, y2 and z2, then the vector joining two points, that is P and Q, vector PQ is given by x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. How we got this? So, this was your x-axis, y-axis and z-axis. So, you have P point P and Q. We need to find what is this vector PQ. So, here the coordinates of Q are x2, y2 and z2, and the coordinates of P is x1, y1 and z1. First, we draw a position vector for the point P. Position vector is that vector whose initial point is 0. So we draw the position vector for the point P, and also we draw a position vector. We have taken a position vector for the point Q. Okay, then we found what is vector PQ by using triangular law of vector addition. That is, vector PQ is given by vector OQ minus vector OP by the triangular law, which says that vector OP plus vector PQ is equal to vector OQ. From this, we got vector PQ is equal to vector OQ minus vector OP. And here, how we wrote this vector? So once we know the coordinate of a point, then we can easily write the position vector. So for the position vector of the point P is given by x1 I cap plus y1 j cap plus z1 k cap. Similarly, the position vector of the point Q with the coordinates x2, y2, z2 can be written as x2 I cap plus y2 j cap plus z2 k cap. Simplifying this, we got the vector joining 2 points. So what is the magnitude of this? So magnitude of the vector PQ is given by root of x2 minus x1 whole square plus y2 minus y1 the whole square plus z2 minus z1 whole square. So z2 minus z1 whole square. This is the magnitude for the vector joining 2 points. Next, we saw how to add or subtract any two vectors. So, if vector A, you have two vectors, say vector A and vector B, they are given in their component form. So, if I consider this to be as A1i cap plus A2j cap plus A3k cap, and you have another vector, say vector B, which is in its component form, which is B1i cap plus B2j cap plus B3k cap, then I can add these two vectors, and vector A plus vector B will be equal to A1 plus B1 into I cap plus A2 plus B2 into j cap plus A3 plus B3 into k cap. This is how we add any two vectors. That is, we add only the I component, so A1 plus B1. Then for j, we add only the j components, A2 plus B2, then A3 plus B3. So if we can add two vectors, we can even subtract. So the subtraction of two vectors is given by A1 minus B1, this minus this, into I cap, plus, here you should write plus, next you have A2 minus B2 into j cap, plus A3 minus B3 into k cap. Okay, so this is about addition and subtraction. If I say the given two vectors, that is vector A and vector B are equal, then what does this imply? If vector A is equal to vector B, then this implies that A1 is equal to B1. That is, the components of I of both the vectors should be same, and also A2 should be equal to B2, and even A3 should be equal to B3. So if these three things are equal, that is A1 is equal to B1, A2 is equal to B2, and A3 is equal to B3, this also implies back that the two vectors are equal. Okay, this is what we have studied, or we have used this formulas in order to solve the problems in our previous class. With this, let us list out few more few more formulas which we will be using in order to solve today's problem. So before I erase this, I want everyone to make a note of it so that this helps you to solve the problem very easily. You can refer to the formulas and you can solve the problems easily. Let us list out a few more formulas. So if we have given any two vector in its component form, let us take the first vector as vector A. So it is given as A1i cap plus A2j cap plus A3k cap, and the second vector, let us take it as vector B. So which is given as B1i cap plus B2j cap plus B3k cap. Then, if I say that these two vectors are collinear, if and only if it satisfies either one of the two conditions. So, either you can prove by a condition where you can prove that vector B is equal to lambda times vector A, where lambda is any scalar. Or, you can even prove using the form B1 by A1 is equal to B2 by A2, which is equal to B3 by A3, which is equal to some lambda. Okay, either you can prove this or you can prove by this method. So if we say that these two vectors are collinear, then you can apply any of these two conditions and you can prove that the given two vectors are collinear. After this, then we have seen if we are given any vector, say xi cap plus yj cap plus zk cap, if I consider this to be as vector A, then if they ask us to find what is its direction ratios and direction cosines, for finding its direction ratios, if you just write its scalar component of the given vector, that will be only your direction ratios. So what are the scalar components here? It is x, y and z. So x, y and z will be your direction ratios. Now how to find its direction cosines? So direction cosines will be given by x, that is the I component first, x divided by root of x square plus y square plus z square, and y divided by root of x square plus y square plus z square. Then we have z divided by root of x square plus y square plus z square. We use this formula in order to find its direction cosine. So this is how we find the direction cosines and direction ratios. Next we studied about section formula. So here we studied two cases. One is the case 1 where we have seen the point R divides the line segment PQ in the ratio m:n internally. So under this condition, the position vector of the point R, which is given by OR, will be equal to m into vector B plus n into vector A divided by n plus n. Next, the second case, where in this case, the point R divides PQ in the ratio m:n externally. So here, the position vector OR is given by m into vector B minus n into vector A divided by m minus n. And we have also seen what is the formula for midpoint. That is, when the point R divides the line segment PQ in an equal ratio, that is, when the ratio m and n are same, that is m is same as n, then the midpoint formula is given by position vector OR will be equal to vector A plus vector B divided by, which can be even written as vector B plus vector A divided by 2. These are the formulas now which we are going to use. With this, even the formulas which I have listed before this, with all these formulas, we are going to proceed with the problems. Let's take up the first question of today's class. That is, show that the vectors 2i cap minus 3j cap plus 4k cap and minus 4i cap plus 6j cap minus 8k cap are collinear. So just now we have solved. In order to prove the two vectors are collinear, either you can use any of the conditions. So you can either prove one of the vector is equal to lambda times the other vector, or you can use the formula b1 by a1 is equal to b2 by a2 is equal to b3 by a3, that is equal to some lambda. Where lambda is your scalar. So let us take the first vector as vector A. So vector A is equal to 2i cap minus 3j cap plus 4k cap, and vector B is equal to minus 4i cap plus 6j cap minus 8k cap. Now I'll consider vector B. So vector B, we know it is equal to 4i cap plus 6j cap minus 8k cap. Now from this I can take minus common and also 2 common. So I am taking minus 2 as a common from the given vector, vector B. So if I take minus 2 common, now this will reduce in the form of 2i cap minus 3j cap plus 4k cap. So what is this 2i cap minus 3j cap plus 4k cap is equal to? It is equal to our vector A. So this can be written as minus 2 times vector A. So this as reduced in the form of vector B is equal to lambda times vector A. This is one of the proofs, or you can even prove it in the form using the formula showing that B1 by A1 is equal to B2 by A2, which is equal to B3 by A3, which is equal to some lambda. You can even use this. So let us see how to prove. So when you consider this as vector A, this will be your A1, A2, A3, and this will be your B1, B2 and B3. So B1 by A1, therefore this will be equal to minus 4 divided by 2. Next, B2 by A2, that is 6 by minus 3, which is equal to B3 by A3 minus 8 by 4. So if you simplify this, see here 2 ones are, 2 twos are. So everything will be equal to minus 2, where minus 2 is again your lambda. Okay, next problem. In the next problem, they've asked us to find the direction ratio for the given vector A, and also we need to calculate its direction cosines. Let us use the formula here. So the given vector A is equal to I cap plus j cap minus 2k cap. Now let us find what is its direction ratios. So as we discussed, direction ratios will be what? It is 1, x, y and z. So what is the value of x here? It is 1. The value of y is also 1 and the value of z is minus 2. So it is 1, 1 and minus 2. Now in order to find its direction cosines, okay, direction cosine. So what is the formula here? It is x divided by root of x square plus y square plus z square, and y divided by root of x square plus y square plus z square, comma, z divided by root of x square plus y square plus z square. Yes? So here, what is the value of x? It is 1. So 1 divided by root of x square plus y square plus z square. Root of, it is fine. Let us simplify. Root of x square, it is what? 1 plus root of y square, again it is 1. So 1 plus 1. Here I am going to simplify. 1 square plus 1 square plus minus 2 the whole square. This is your x square plus y square plus z square. So when I simplify this, what will I get? It is 1 plus 1 plus 4. So 1 plus 1 plus 4, it is root 6. So next, y. What is the value of y? Y, 1 divided by root of, when I simplify x square plus y square plus z square, again I get 6 here. Then you have z minus 2 divided by root 6. So you should be able to do it even not by writing this. You can directly do it because these are simple numbers. Now, when coming to your next problem, again they've asked us to find what is the direction cosine for the given vector. So let us call that given vector as vector A, which is I cap plus 2j cap plus 3k cap. So in this problem, let us write it directly, even without writing its formula. So direction cosine is given by, so you are, what is the value of x? 1, y is 2, z is 3. So 1 divided by root of x square plus y square plus z square. 1 square, it is 1, 2 square, it is 4, 3 square, it is 9. So, okay, 1 square, 2 square plus 3 square. Then you have 2 divided by root of 1 square plus 2 square plus 3 square. Then you have 3 divided by root of 1 square plus 2 square plus 3 square. So simplifying, you will get this as 1 divided by 3 square is 9, 9 plus 1 10, 10 plus 4, it is 14. So 1 by root 14, 2 by root 14, and you have 3 by root 14. This is how we find the direction cosines. So in the next problem, here also we need to find direction cosine. So find the direction cosine of the vector joining the points. So joining the points A and B directed from A to B. So here first we need to use vector joining 2 points and find the vector AB. Then for that vector AB we need to find the direction cosines. So let us first find what is vector AB. So vector AB. So vector joining 2 points. So it is given by x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. So the initial point you should consider, its coordinate you should consider as x1, y1, z1, and the terminal point coordinate you should consider as x2, y2 and z2. So this will be your x1, y1, z1 because they have told directed from A to B. Initial point is A, terminal point is B. So your B coordinates we should consider it as x2, y2 and z2. So vector AB is given by x2 minus x1. So x2 is minus 1 minus x1 it is what? 1 into I cap plus y2 minus y1. So y2 is minus 2 into j cap plus z2 minus z1 it is 1 minus of minus 3 into k cap. So simplifying this, we'll get it as minus 2i cap, then minus 4j cap, then we have plus 4k cap. So we got the vector. For this vector, we need to find the direction cosine. So direction cosine for the vector AB is given by, so same formula again, x by root of x square plus y square plus z square, x by root of x square plus y square plus z square, comma, y by root of x square plus y square plus z square, comma, z by root of x square plus y square plus z square. So x, what is the value of x here? It is minus 2. Y, which is minus 4. Z, which is plus 4. So it is minus 2 divided by root of, so it is simplified directly, x square, that is minus 2 whole square, which will be equal to what? 4. Then plus y square, minus 4 whole square, which is 16. Plus again 4 square, so it is 16. Next you have what? Y value is minus 4 divided by root of 4 plus 16 plus 16. Next, plus 4 divided by root of 4 plus 16 plus 16. So final you will get minus 2 divided by 16 plus 4 20, 20 plus 16 36, root of 36 is 6. Then minus 4 divided by 6, which is 4 by 6. Further, if we simplify, this will be equal to minus 1 by 3, minus 2 by 3 and 2 by 3. So, the direction cosine for the vector AB is given by minus 1 by 3, minus 2 by 3 and 2 by 3. Next question. Show that the vector I cap plus j cap plus k cap is equally inclined on the axis OX, OY, OZ. That is, if I consider this to be as any vector, say vector A, which is given by I cap plus j cap plus k cap, okay, we need to show that this vector is actually making equal inclination, that is, the angle made by this vector with the x-axis, we call it as alpha, and the angle made with by this vector with the positive direction of y-axis, we told it as beta, and similarly with the z-axis, we call it as gamma. What we need to prove is, we need to show that alpha, beta and gamma are equal. In order to prove that alpha, beta and gamma are equal, first let us find what is cos alpha, cos beta, cos gamma. What are cos alpha, cos beta, cos gamma? They are nothing but our direction cosines. So let us find the direction cosines for this. So let us take the given vector as vector A, which is I cap plus j cap plus k cap. Let us find what is its direction cosine. So it is x divided by root of x square plus y square plus z square and y divided by root of x square plus y square plus z square and z divided by root of x square plus y square plus z square. So x is 1 divided by root of x square plus y square plus z square. 1 square plus 1 square plus 1 square. What is 1 square? It is 1. 1 plus 1 plus 1. It is 3. I wrote it directly. This is easy. Therefore, again, this will be 1 by root 3. This is 1 by root 3. Therefore, I can say cos alpha here is same as cos beta, which is same as cos gamma, which is equal to 1 by root 3. Because cos alpha is nothing but x by root of x square plus y square plus z square. Even cos beta is y by root of x square plus y square plus z square, and cos gamma is z by root of x square plus y square plus z square. All are equal to what? Equal to 1 by root 3. From this, I can say alpha is same as beta, which is same as gamma. So the angle made by the vectors, which we have called as vector A, is same. So we can conclude that this vector is equally inclined along the axis OX, OY and OZ. Next problem. This problem is based on section formula. Here, they have considered 2 points P and Q with position vector. That is the position vector of the point P. Vector OP is given by 3 times vector A minus 2 times vector B, and OQ, vector OQ is given by vector A plus vector B. Find the position vector of the pointer. That is, we need to find what is vector OR, which divides the line joining PQ in the ratio 2:1. That is the ratio m is to n. Here they mention it as 2:1. First case for both internally and externally you should do. So let us take up the first case. So before taking up the first case, the first vector which they have given, you should consider as vector A. Don't get confused with this. What is this vector A again vector B? They are not actually directly mentioned in its component form. So vector A, any vector in its component form, vector B, any vector in its component form. So if we simplify again, we get back a vector itself. So when we add or subtract 2 vectors, we get back a vector. So first vector, let us take it as vector A, and the second vector we consider it as vector B. The ratio 2:n is nothing but m is to n. That is, m value is 2, n value is 1. So for the case 1, that is called internally. What is the formula? The position vector OR is given by m into vector B bar plus n into vector A divided by n plus n. So what is the value of m here? It is 2 vector B. That is your second vector which is given in your question, which is vector A plus vector B plus n. N is 1, vector A, the first vector given in the question. So 3 times vector A minus 2 times vector B whole divided by n plus n, that is 2 plus 1. Simplifying. So position vector OR is equal to 2 times vector A plus 2 times vector B. Here I am multiplying 2 inside, then plus multiplying 1. So we get 3 times vector A minus 2 times vector B divided by 2 plus 1, which is equal to 3. So if you see in the numerator, plus 2 times vector B minus 2 times vector B get cancelled. So simplifying, 2 times vector A plus 3 times vector A will be equal to 5 times vector A whole divided by 3. The second case, which is for external division. So what is the position vector OR is given here? It is given as m into vector B minus n into vector A divided by m minus n. So this is equal to 2 into vector B is vector A plus vector B minus n value is 1. Vector A is 3 times vector A minus 2 times vector B divided by 2 minus 1. So simplifying further, it is 2 times vector A plus 2 times vector B minus 3 times vector A plus 2 times vector B divided by 2 minus 1, which is equal to 1. Therefore, this is equal to, so here 2 times vector A minus 3 times vector A will be equal to minus vector A. Then you have 2 times vector B plus 2 times vector B, which is 4 times vector B whole divided by 1. Remember students, whenever you are writing a vector, you should mention this. This is how we represent a vector. Without that, you will be not awarded any marks. Next problem, we need to find the position vector or where the given two vectors are I cap plus 2j cap minus k cap and I cap minus I cap plus j cap minus k cap. These are the points P and Q, which is divided by a point R in the ratio 2:1. We need to find what is the position vector for the point R for both the cases. So first case, internally. So before actually writing, let us name the given two vectors. So the first vector which is given, I'll name it as vector A, which is I cap plus 2j cap minus k cap, and the second vector which is vector B minus I cap plus j cap plus k cap. So for the first case, we have the position vector OR is given by m into vector B plus m into vector A divided by n plus n. Therefore, this will be equal to m. M is 2, n is 1. Therefore, 2 times vector B. Vector B is minus I cap plus j cap plus k cap plus 1 into vector A. So, what is your vector A? It is I cap plus 2j cap plus k cap whole divided by m plus n. M plus n is 2 plus 1. So simplifying this will be equal to minus 2i cap plus 2j cap plus 2k cap, then plus I cap plus 2j cap plus k cap whole divided by 3. So this will be equal to minus 2i cap plus I cap is equal to minus I cap. Then plus 2j cap plus 2j cap, which is equal to plus 4j cap. Then we have plus 2k cap plus k cap, which is plus 3k cap whole divided by 3. So next case for external division, we have vector OR is equal to mb bar minus na bar by m minus n. So m, which is 2 into vector B, which is minus I cap plus j cap plus k cap minus 1 into. So your vector A, which is I cap plus 2j cap minus k cap whole divided by 2 minus 1. Therefore, this is equal to minus 2I cap plus 2j cap plus 2k cap, then multiplying this minus 1 inside, minus I cap minus 2j cap plus k cap divided by 2 minus 1, which is equal to 1. So this is equal to minus 2i cap minus I cap, which is minus 3i cap. Then plus 2j cap minus 2j cap, it is 0j cap. Then if you don't write also, it is understood that it is 0. Then 2k cap plus 2k cap, which is plus 3k cap whole divided by 1. So next, moving on to the next problem. Here you need to find the position vector of the midpoint of the vector joining the points P and Q. So they are given P and Q, point P and point Q with their coordinates. So first let us write it in the vector form. So vector OP, which I call it as vector A, which is equal to 2 times I cap plus 3 times j cap plus 4 k cap. Next, the second vector, vector OQ, for the point Q, OQ, I take it as vector B, which is equal to 4i cap plus 1j cap minus 2k cap. So here, what we need to find? We need to find midpoint. It is understood when we are finding the midpoint, the ratios are same. So what is the formula for that? The position vector is given by vector A plus vector B divided by 2. Therefore, this is equal to, what is your vector A? 2i cap plus 3j cap plus 4k cap plus vector b. Now vector b is given by 4I cap plus 1j cap minus 2k cap whole divided by 2. So simplifying this will be equal to 2I cap plus 4I cap, which is 6I cap. Then 3I cap plus 1I cap plus 4j cap. 3j cap plus 1j cap is 4j cap. Next you have 4k cap minus 2k cap, which is plus 2k cap whole divided by 2. So how you can simplify it further? By taking 2 common in the numerator. If I take 2 common in the numerator, I will get 2 times 3I cap plus 2j cap plus k cap whole divided by 2. So 2 and 2 get cancelled. So the final answer will be equal to 3I cap plus 2j cap plus k cap. Next problem. Show that the points A. Here actually they are given in vector form itself. That is, if they are given in the point coordinate, then it will be 2, minus 1 and 1. 2, minus 1 and 1. So directly they have given in the vector form. Next they have given B. The points, the coordinates of this point B is 1, minus 3 and minus 5. C with the coordinates 3, minus 4 and minus 4 are the vertices of right angle triangle. We need to prove these 3 are the vertices of right angle triangle. So in order to prove that, here we will be using Pythagoras theorem. That is, the hypotenuse square is equal to sum of the square of the other 2 sides. So in order to find hypotenuse, we need length. So we need length means it is nothing but a magnitude. So we need to find the magnitude of the sides of the triangle. So for now, I don't know which is my hypotenuse. In general, if I take A, B, C, if I know what is vector AB, then vector AB, vector BC, and vector CA, I'll be able to find the magnitude of this vector, means this magnitude. So with the magnitude, I'll be able to know which is our hypotenuse, and will be able to prove whether these 3 points are the vertices of right angle triangle or not. So in order to prove that, so first they have given the points, means they have given actually what is a vector position vector. For the point A, they have given the vector. So that is your position vector. So position vector OA is given by 2I cap minus j cap plus k cap. Then next they have given the position vector. So position vector OB is given by I cap minus 3j cap minus 5k cap. Then position vector OC is given by 3I cap minus 4j cap minus 4k cap. We need to find what is AB means. We need to find AB means it is nothing but we are finding a vector joining the 2 points. Okay, in order to find the vector joining the 2 points, this is directed from A to B. We'll be using which formula? X2 minus x1 I cap plus y2 minus y1 j cap, z2 minus z1 k cap. So here I need to find vector AB means this can even be written as vector OB minus vector OA. This is because of where we have solved for vector joining 2 points. We had vector PQ, this was the position vector O to P. Then we wrote vector OQ is vector OQ plus vector PQ is equal to vector OQ. So PQ vector can be written as vector OQ minus vector OP. With this result, we can even write like this means when you have a vector, this is P is your initial point and Q is your terminal point in this example. Therefore, that can be written as position vector of the terminal point minus the position vector of the initial point. So, with the same concept, here A to B, initial point is A, terminal point is B. So, position vector of the point B minus position vector of the point A with that concept. Okay. So, vector OB is what? I cap minus 3j cap minus 5k cap minus vector OA, which is 2I cap minus j cap plus k cap. Therefore, simplifying, I cap minus 3j cap minus 5k cap minus 2I cap plus j cap minus k cap. So, I cap minus 2I cap minus I cap, then minus 3j cap plus j cap, which is minus 2j cap minus 5k cap minus k cap, which will be equal to 6 minus 6k cap. After this, let us even find what is the vector joining the points B and C, then similarly C and A. So, vector joining the point BC. So, vector BC can be now written as what? Vector OC minus vector OB. So, vector OC, which is 3I cap minus 4j cap minus 4k cap minus vector OB I cap minus 3j cap minus 5k cap. So this is equal to 3I cap minus 4j cap minus 4k cap minus, multiply this minus inside, minus I cap plus 3j cap plus 5k cap. So this is equal to 3I cap minus I cap, which is 2I cap, minus 4j cap plus 3j cap minus j cap, minus 4k cap plus 5k cap plus k cap. Now let us find what is C, vector joining point C and A, which can be written as OA vector minus OC vector. So vector OA is given by 2I cap minus k cap plus k cap minus vector OC, which is 3I cap minus 4j cap minus 4k cap. So here this is equal to 2I cap minus k cap plus k cap minus 3I cap plus 4k cap plus 4k cap. Okay, so this is equal to 2I cap minus 3I cap minus I cap minus j cap plus 4j cap plus 3j cap plus k cap plus 4k cap plus 5k cap. Now we are finished with finding the vector joining the points. That is, we know what is this, what is vector AD, what is vector BC, and what is vector CA. We need to find their magnitude now. So let us find the magnitude. So first, magnitude of vector AB is equal to, so how to find magnitude? Root of x square plus y square plus z square. So what is the value of x here? It is minus 1, y is minus 2, z is minus 6. Therefore, this is root of minus 1 whole square. It is 1 plus, okay, for understanding I am going to write here minus 1 whole square, then minus 2 whole square plus minus 6 whole square. So this is equal to 1 plus 4 plus 36. Therefore, this is equal to root 41. Next, finding the magnitude of BC. Therefore, this is equal to root of, you have 2 square plus minus 1 the whole square plus 1 square. Therefore, which is 4 plus 1 plus 1, which is equal to root 6. Then magnitude of vector CA is equal to root of minus 1 the whole square plus 3 square plus 5 square. So which is 1 plus 9 plus 25, which is equal to root 35. Now, in order to prove, that is, these are the vertices of right angle triangle, I am going to use Pythagoras theorem. So when you observe this, so you have AD as, magnitude of AD as root 41, magnitude of BC as root 6, and magnitude of CA as root 35. When you observe, we know that hypotenuse will be having greater, more length. So here I consider AD as hypotenuse. So hypotenuse square should be equal to sum of the square of the other two sides. So that is magnitude of BC square plus magnitude of CA square. So what is magnitude of BC? Which is root 6 for this whole square. Magnitude of BC is root 6 whole square plus root 35 whole square. So this will be 6 plus 35 and 6 plus 35 is 41. Where magnitude of AB, which is given by 41, root 41, the whole square when you do, it will be also equal to 41. So by this we have proved that the given vertices are the vertices of the given points are the vertices of right angled triangle. There are problems where we sometimes we may even get they are not. So there you can write not equal to, and you can conclude that the vertices, the given points are not the vertices of right angle triangle. With this, I am going to finish the problems for today. In the coming classes, let us let us understand few more concepts on vectors. That is, we will be studying the vector product. Okay, there are different types of product in vectors. Means there are different types. So there you will be studying scalar product and vector product, which is also called as dot product and cross product.